Hello.
Hello. Good morning,
Yeah,
sir.
good,
Shashma here.
yeah, good morning.
Yes, sir. You can try sharing the screen.
Okay. Am I visible? Yeah.
Yes. Yes, sir.
Okay. So now for sharing, this I can make a bigger screen, and then for sharing, what need to be done for sharing?
Click on the share button, sir.
But share button is not visible here.
No, it will be visible, sir. Green share button.
It is on participants, chat, react, share. Yeah, it is green. Just come. So I put this green. Okay.
Click on the share sound, which is on the right side also.
Yes, yes. This is what you told yesterday as well. I did
Entire
this
screen.
entire screen. Yes, this I will do. Is coming.
Yes, sir. Now you can open the presentation.
Presentation for opening. I have to go to the desktop. So should I minimize it?
Yes.
Okay, minimize and then okay, and then I can make it. Cup. Is it fine?
Yes, sir. Perfect.
So
Just
this
go ahead. I want to check for the sound, sir.
okay. Madam, that extreme right, like your Sushma, then yourself, Sumit Kataria,
No
those.
problem, sir. That I am not able to see. I can see only your presentation.
I know, there's not a problem. But okay, I can minimize it. No, because while reading,
You can drag that, sir.
fine. Okay, fine. Agreed. Because it was interfering with
Or click
some.
on the minus sign. There will be one minus
Yes,
sign.
yes. It was there. I think that is fine. And then now that we will check as you are mentioning some sound. It is there.
Yes.
Fine. Then
Okay.
everything will be fine.
Yes, sir.
So I can escape and go to the original one.
Yes, sir. You can close this. Stop share.
Stop share. That means I had to go. Oh, yeah, stop share. Okay. So this is the stop share. I can put a button here, and that's
Yes. Perfect, sir.
okay. Right.
Now you can off the camera. When it will start, when I introduce you, you can on the cameras.
So camera, yes. That's fine.
Okay, sir. Yeah.
क्या ना करना, 3-4 मिनट बाकी है तो उसके बाद बंद हो जाएगा, चालू हो जाएगा।
कब तक बुड्ढा रहेगा इस समय में? कब से कब तक बुड्ढा रहेगा? 1 बजे तक पूरा? थोड़ा बीच में यहाँ पानी रख लिया हैं?
Good morning, everyone. Myself, Shushma Kindalkar. I am your host for today. I welcome each and everyone for the Sadgun Sang Meet, which is the 243rd virtual webinar. The topic for today is Atoms to Action, Nuclear Science Driving India's Sustainable Development Journey. This shall be taken by Dr. Chetan Prakash Kaushik, followed by question and answer session. Agenda for today's Sadgun Sang Meet. We'll have a virtual inauguration by Dr. Sundar Kataria, invoking the blessing of deity, introduction of the speaker, presentation by Mr. Dr. Chetan Prakash Kaushik, followed by question and answer session. About Sadgun Sang. Sadgun Sang conceived and led by Dr. Sundar Kataria, driven with a mission to elevate the quality, safety, and environmental awareness levels of industry. Sadgun Sang is a series of educative, informative events aiming to illuminate professionals on possible solutions to current issues of industry and economy. Introduction about Dr. Kataria. He is the Chairman and Managing Director at International Certification Services Private Limited. He has done mechanical engineering from AMIE, honorary doctorate into business management. His experience is into nuclear RAPP. He started his career in building India's first nuclear power plant at Rawat Bata, Kota, Rajasthan. Oil and gas EIL. He contributed in developing India's first oil and gas field at Bombay High since its inception. DNV. He was the head of industry and offshore development with DNV for 2 decades. ICS. He is the founder of first Indian conformity assessment and inspection body known as International Certification Services Private Limited, which is a provider of total quality solution under single umbrella with a wide spectrum of services. His achievement, Lifetime Achievement Award of NACE Corcon, received several national and international awards. I request Dr. Kataria to virtually inaugurate today's session.
शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शत्रुबुद्धिविनाशाय दीपज्योतिर्नमोऽस्तुते दीपज्योतिर्नमोऽस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Please join us for the recitation of Gayatri Mantra. Introduction of the keynote speaker. Dr. Chetan Prakash Kaushik. He's an outstanding scientist and former director at Nuclear Recycle Group, BARC. Over 36 years in nuclear science and technology, quality management systems, health and safety, environmental safety, and regulatory compliance. Dr. Kaushik has conducted numerous comprehensive audits in QMS, health and safety, and environmental domains, ensuring adherence to global operational standards of excellence. He has made remarkable academic contributions, authoring over 150 research publications in reputed international journals. His pivotal contributions include serving as a member of the International Waste Safety Standards Committee at the International Atomic Energy Agency, Vienna, where he played a key role in developing critical global safety standards. He has written several authoritative chapters on radioactive waste management, thorium reserves, and their utilization, and non-nuclear applications of nuclear science, showcasing his extensive expertise and forward-thinking approach. He has been elected a Fellow of the National Academy of Engineering, FNAE, a prestigious recognition of his outstanding contribution to engineering and technology, and have over 150 publications in peer-reviewed international journals. He has also received Homi Bhabha Science and Technology and Haryana Vigyan Ratna Award for his exceptional contributions to science, technology, and innovation. I welcome Dr. Chetan sir. I request to take this session ahead, sir. Thank you so much. So I request you to unmute yourself.
Yeah, thank you so much for kind words of introduction. May I share now?
Yes, sir, you can.
Share entire screen. So, good morning to everyone. And at the outset, let me check whether my voice and presentation is audible, is visible. Whether I'm audible. Hello. Am I audible? Yeah, fine. That's fine. And the screen also is visible. In that case, at the outset, I thank the organizers for giving me an opportunity on this important platform to share some of the works being done by our team in the area of nuclear science and technology, where atoms come into actions, contributing an important path significantly in sustainable development of the journey. So in the slides, I will be indicating some sort of the stations which I will be covering through the journey, where I will be looking about or I will be sharing about the present status of electricity demands and options available to us, and will like to show that nuclear energy can play an important role in this. And then when we talk about nuclear energy or technology, then I will be touching on what are the fuel cycle options, and then what we say about closed fuel cycles. Then I say what we mean by back end of nuclear fuel cycles, which includes reprocessing and advancements. Then management practices for radioactive waste, which is an important component of nuclear fuel cycle. Normally, we call them as a spent fuel management as well. And then advancements in waste management practices as science is getting evolved over a period of time. And then what are the important offshoot applications of this development? And more importantly, also how this development, which has been done almost maybe only a decade earlier, and how the international scientific community is viewing our country with respect to these developments. And then I may summarize. So if you look at the maybe imaginary situation, if you look at world from the sky, and then look from the space, if you look the Earth, you will find that some part of the Earth is a brighter compared to other, and maybe in that case the USA, Europe, and maybe Japan, and to some extent India. What I'm talking about is basically per person consumption of electricity, which is by and large a direct measure of development index as a whole. So if you look at India as of now, we are somewhere maybe around 1,300. This is the value what is from 2020. There has been improvement, but maybe now we are at 1,350 or 1,400 kilowatt hour. And if you look at the advanced countries, they are even like Canada, then it is around 15,000 odd numbers, USA, and the world average is something also even more than 10,000. And this slide shows that there is a good, there's a big gap between the demand and supply. And even now, if you take a look at worldwide, still we may be lucky enough who are staying in cities and all, but still there is a good number, 13% of the world population, and even equivalent or around 15% of Indian population has yet to see the benefits of electricity. And that shows that electricity is playing important role in the sustainable and journey. Now, question comes: what are the different paths or different versions available to us? As of now, we know that coal. If you look at in 2018 data, we were almost more than 60% of the energy was coming from coal, and now government of India seeing the after effects of coal, the CO2 getting pumped into the atmosphere, and there has been a lot of incentives of renewable energies, and as a result, the 61% got reduced to 53.6%. Let me remind all my worthy members, our honorable Prime Minister of our country, Modi ji, already has, you can say, declared international globally that by 2047 we will be working somewhere with the 100 gigawatt electricity from nuclear, and 2070 there will be a net zero. That means net zero carbon means there will not be any energy getting derived from coal, which means that other parts like renewable and all, they need to be given more and more importance. Accordingly, Government of India has been giving a lot of incentives for renewable energy. As of now, you talk about, then we are banking heavily on what is called energy mix, because of the obvious reason that there is a big gap between the demand and the supply. Now, if you look at about even the what is in terms of GDP also, that is gross domestic product, and even if we aim an average of around 8%, then also which we will be needing, if even if we say a growth of 9% or 8%, we'll be needing electricity of something around 800 gigawatt electric. And as of now, the statistical data shows even if we fully concentrate on renewable plus hydro, even if we work more and all, then also we'll be able to reach something, a figure of 250 or 300 gigawatt electric. That means still there is a big gap. And what I'm essentially trying to say, only renewable, only solar and hydrothermal will not, I can underline the word, will not be able to meet the ever increasing demands of electricity. Does it mean that this gap, what is shown from the green line, it means that CO2 again will continue to be playing an important role, and meeting this requirement, that means if we have to bank on burning fossil fuels, need not be coal, even oil, and all, would essentially mean that 3 to 4 billion tons of CO2 will be getting again pumped into the environment. So we have to think that how these things can be handled. Now, if you look at the remaining sources, what we have, as I told, solar you have, and from the left-hand side, and then here I'm talking about the nuclear part, and the bottom we are working on the. So there is a major contributor as of now is coal, and which almost every now and then we have been having a good concentration of CO2 getting pumped into the atmosphere. So if you look at why we are so worrying about CO2 getting pumped into the atmosphere because of global warming, and what does it mean? Is it only a academic interest, or are we are able to see the visible changes of this global energy? So it is not only a virtual part, rather it is now a real scenario. It is a real part, and it has started showing its signature at different ways. For example, if you look at floods in North India, typhoons in China, hurricanes Dori, there are many such examples, and essentially CO2 is playing important role in warming the earth. If you look at the first graph, global temperature, and if you look at from the industrial revolution, maybe something around maybe 1900 onwards. Earlier we had a green revolution, which was basically on crops and all, and then we started working on green industrial revolution. And that time, only and only we were banking on coal. And from 1900 to as of now, there has been the graph itself clearly indicates that there has been a steep rise of maybe something around 1.5 degrees Celsius or so in the temperature of the earth. And looking wise, the figure 1.5, if you look at it, may not look that serious, but it has got serious consequences, and resulting into the melting of ice in the glaciers, resulting into the sea change, sea levels high up, and which eventually will make that the coastal area cities and all, will be getting submerged in the water. Now, have you seen? If you look at the air composition, we look at the simple, nothing nuclear so far. If you look at the air composition, which essentially contains from nitrogen and oxygen. If you talk about nitrogen and oxygen, probably more than 90% and all we are able to cover. Then remainings are only water vapors, and then carbon dioxides and methane. Then question comes when the bulk, more than 95% or 99%, things are fine. Why we need to bother about remaining 1%? Is whether the presence of 1% also can be a cause of concern about it. The usually CO2 and methane, in fact mainly CO2, why they are called as a greenhouse gases, why not others? So if you look at the composition of CO2, see, and these process property absorbing, in fact CO2, what it does, we know very well that when during the sun, it is emitting different radiation of energies, and I'm sure the audience to whom I am talking about, energy and wavelength are, these two are the characteristic property how to define radiations. So radiations of different energy, starting from ultraviolet, from infrared. So nitrogen and oxygen, they are almost a silent player when the radiations comes, and it is the CO2 which absorbs the infrared radiations coming from the sun, and once it absorbs, gets involved into the because the energy of infrared radiations is sufficient to play with to break the bond of CO2. Now, question comes: why? Again, it's still nothing nuclear. It's a basic science. Why nitrogen and oxygen remains silent when infrared? Why they are not absorbing infrared radiations. So there has to be a change in dipole moment. Then this is again a word of science. And then CO2 is IR active. That means it interacts with infrared radiation, and as a result, when it is again the radiation getting absorbed when they come from sun, and again when from after reflecting from the earth, when it is going towards, again it finds its friend CO2 again, and then again it is getting absorbed. As a result, it warms the earth temperature. That's how CO2 and methane as well also doing a similar thing, but the concentration of methane is much less. Even water vapor also do a similar action, but among all the three, the major player for affecting the temperature is CO2. And we all know that including vehicular movements and all, but the lion's share comes from our thermal power plants, where huge amount of CO2 is getting pumped into the atmosphere. This is what I was trying to tell, that oxygen is almost not playing, and your NO2 and your N2 and O2 is not playing any role, but CO2, methane, and water vapors, they are able to react with the infrared radiation and then get involved into the chemical changes. But N2 and N2, there is no dipole moment, so they remain a silent player in this. Now, again, the greenhouse gases cause of global warming. This is what I was trying to tell, that sun rays comes and then they meet other constituents of air, but there are silent constituents like O2 and N2. But the moment these radiations meet CO2, they're getting absorbed. And when they are reflecting, when the earth reflects them back, again, they are getting absorbed because of presence of CO2. And now if you look at, I was mentioning about 1900. So that time, if you look at the data, average concentration of CO2 was something around 150 to 200 ppm. And if you look at as of now, if the Google's and other data will show, we have touched around 400 ppm. Now that means, see, CO2 is important for habitable planet. Let's imagine a situation when CO2 would have not been there. The CO2 would have been zero. That means that time the temperature of the earth would have become minus some 200, or that means human civilization would have not existed. That means CO2 is equally important. But our elders and all, we have been telling excess of everything is bad. So now the 200 has gone to 400, which has started showing its results. And it is predicted by the modeling data. If no serious attempt is done to stop this part, then the consequences will be even much serious in nature. So again, some of the paper cuttings I have seen that this is again a Hindi paper which I have just taken for the information that 20 साल में इतनी गर्मी बढ़ेगी कि जीना बहुत मुश्किल हो जाएगा, and all. This is what typhoon and flood in China. Now that means earlier it was only in scientific investigations, scientific papers publishing in journals, but now the presence is felt in 3 dimensions. Again, look, even this year also I could get out some of the papers. Climate पर 2025 में आएगा कितना change. That means now there is a sufficient sensitization that this is a New Bharat Times of December 24, that the impact is being sensed by public at large. Now, Dubai बारिश में हाहाकार and all those. That means there has to be now the scientific observation has sensitized the public and policy makers to look something serious about it. And look at if you look at a key player in why I was telling nuclear energy is a game changer in the fight against climate change. It is a low carbon footprint. Now footprint, if you look at, and I start with the coal. So if we are using 1 kilowatt hour, I'm very sure my colleagues who are attending or listening, they will be knowing 1 unit of electricity is called 1 kilowatt hour. And if we consume one kilowatt hour, 1 unit, we are having around 820 grams of CO2 getting released into the atmosphere. Then you have a natural gas, we have a solar, and nuclear is having only around 12 grams. That is showing that it is having a minimal footprints. It is by and large equivalent to a renewable energy options there. So question comes when we talk about nuclear, what we mean, what we understand, because the one of the strange or unique thing which has happened with nuclear, which has not happened, I underline, with anybody else, anything else, is if you remember when the process of nuclear fission was invented. It is invented in 1939, whereby Strassman and Hartmann, they were the scientists. They started finding this part. And in 1942, the World War, we hardly some 3-year gap, and the first use of this invention, I repeat, the first use of this invention has gone for a destructive purpose in Hiroshima and Nagasaki. And that really has a very serious impact on the mind of human being all over the globe. And that is the result why even now, it was a long time, 1942, and today we are in 2025, in spite of a big time gap, even now, even the highest intellectual people around, whenever we heard about nuclear, normally we mean like this. But the truth is different. Truth is different, as now if you look at there has been conference of parties, because scientists have done their job. They could sensitize the policymakers about CO2 getting increased into the atmosphere, and if nothing is done seriously, then it will have a serious consequences. Because of that, the policymakers along the globe, they have now they could realize the sensitivity of and seriousness of this, and then the worldwide yearly conference is done to how, because these gases and CO2 and all, they does not know any boundary. Hindustan, Pakistan, USA, our God has given a same sky to all of us. So globally, it has to be met. So because of that, and they are meeting yearly, and that's what I was trying to tell, that our honorable Prime Minister has given a commitment that we'll have a net zero carbon emission by 2070. And together for our planet. Now, the advanced countries in UK, France, USA, Canada, they have started thinking seriously about the next generation of nuclear reactors, which are inherently safe, and so that they can have collectively put efforts to have zero or near zero carbon. And this is the recent photographs in February 2025. This year itself, when press statement by Prime Minister Narendra Modi ji during the India-USA joint conference in the nuclear energy sector, we also talked about increasing cooperation in the direction of small modular reactors. Look at the policymakers have now started thinking seriously about it. And coming back to just give you a glance about wind, solar, and how to compare with the nuclear. Wind and solar are important, but look at their capacities. Wind has capacity of 25%, and solar has capacity as of now to 20%, because I'm sure you may be aware that we still globally also we are working on how to store those energy which is there in the sun, so that we can utilize when sun is not available. So capacity factor, how we define, is electricity produced and divided by maximum installed capacity. And if you talk about the nuclear, as of now, we are having around more than 90% in the capacity of nuclear power. Now, if you compare just the same thermal power nuclear, and just to give some sort of the area required or the waste getting generated from the wind and this from the if you have the average capacity factor is 93.8% in case of a nuclear. In comparison, we have around 30.2 and covered area. This point I wanted to have your attention, and the covered area 380 kilometers square, and in comparison to 1.6, one can look can we wholly depend on wind because a agriculture country where a lot of our population, the largest in the world, needs food to have a sufficient growth or of our food grains and all, we'll be needing cultivation of lands and all. So this area looks to be very, very high. Now, if you look at the atom, or they are now the power of prosperity, because nuclear is electricity is one, but I'm sure many of you are maybe aware nuclear is playing a key role as of now. When I say indispensable role, rather maybe a better word, and in health sector, in sector of food, in water, in environment, of course, national security, and even the technology development, and in industry. I can give examples for all. Rather, some of the examples also I will be covering during the course of presentations. Now you look at this, how this atom can become a source of energy. This one has to go back in the paper published by in almost probably, if my memory goes right, in 1905. 1905. Now 1905 there was a paper published by our what is called our one of the scientists, the father of can say which makes the basis of nuclear energy, by Albert Einstein, where he indicated the E is equal to mc square, and that paper published in 1905 becomes the basis of nuclear energy, and which indicated that mass energy are interconvertible. And just to give an example so that one can really appreciate the source house of energy statement, that if you look at maybe 2 bundles of uranium, which is a fuel of 27 kg each, and if you say the energy equivalent, one has to really have a big amount of coal equivalent to 700 tons. Itself reflects what we mean when we say the source house of energy. And if you look at the history of radioactivity, I'm very sure all of you must have heard the name of Marie Curie, then Madame Marie Curie, and then Henry Becquerel. Let me just give an information. Maybe it must be aware, you may be known to you all as well. Marie Curie is only the one lady scientist or woman scientist in the world, so who has got Nobel Prize in 2 subjects, in chemistry as well as in physics. As of now, the second person is not yet come who has got the prize in both the main subjects, chemistry and physics. To give the honor and to Madame Curie, even now what we have done, what the scientific community has done worldwide, that unit of radioactivity is given in terms of Curie, Curie per liter. So the unit is now named in the honor of Madame Curie. Similarly, Henry Becquerel, another you can say scientist popularly known as father of radioactivity. So this is again SI unit is in Becquerel. So 1 Curie, the relationship between Curie and Becquerel is 1 Curie is 3.7 into 10^10 Becquerel. Now radioactivity materials, when we say nuclear fuel, the way coal is being used as a fuel in a coal thermal power plant and gas in a thermal, in a gas-based power stations. Similarly, here the fuel will be what we say uranium. Here we divide the fuel in 2 parts. One is called fissile fuel. The fissile fuel means which can undergo fission and give us a huge amount of energy. Another is fertile. That means it is not fissible. It is not fissile. With the neutrons, it will not undergo fission. Rather, in the reactor, it will interact with the neutron, not undergoing fission, but it will make another fissile material. So fuel we are dividing in two parts. One is called fissile material, another is called fertile material. Fissile material are those which are undergoing fission directly. To name, uranium-235, plutonium-239. These two are called uranium-233. These are all called fissile materials. On the other hand, thorium-232 is fertile material. Uranium-238 is fertile material. This becomes important for all of us to know because we means India, we don't have a good reserves of fuel as of now in the good reserves of uranium, but Almighty has compensated by giving one third of world reserves of thorium to our country. So thorium is a fertile material, and Indian strategy is if we have to go ahead, we have to have a self-sufficient. We should be able to stand on our own feet when the fuel comes. So we are working to thorium as a fertile material, how it best can be converted into uranium-233, which is a fissile material. Now, if you talk about when this 42, we have seen the use of fission for a destructive purpose, but when we started looking in the peaceful use of nuclear energy, and then that Fermi, and they started working material as with the 235 as a graphite moderators. This is a picture of a small natural. They were trying to use for generation of electricity. How they started when they were looking from a zero onwards. And now coming back to Indian part, we made Apsara, the name of the reactor, in 1956. And let me tell you that that time we were first in Asia. This was the vision of Dr. Homi Jahangir Bhabha, who is also known as the architect of nuclear energy program in our country. So he is the founder of India's nuclear program, and he made the first reactor operational way back in 1956, being first in Asia, because he was knowing that nuclear will be important not only for production of electricity with very low carbon emission, but at the same time it will have important signatures in other departments which covering health, food, electricity, cutting edge science and technology, and national security. So as I was mentioning, we have a 3-stage program for standing on our own feet with respect to nuclear fuel. And I told thorium is good resource in the country. So the first part we are having called pressurized heavy water reactor. This is the first part of we have in our country. As of now, around more than 25 reactors are operating commercially, producing electricity. As if you talk about today, maybe around 8,500 megawatt electric. That means 8,500 megawatt electricity is getting generated as of now in India from these nuclear reactors, which are working on PSWR, where natural uranium is used. And I told we don't have a good reserves of natural uranium. Maybe we had to import as well. So natural uranium has got only 0.7% of, I repeat, 0.7% of 235, remaining 99.3% of uranium-238. And when it is in the reactor, both the isotope 235 is participating into the nuclear fission reaction, and 238 is a fertile. It picks up neutron and gives us another fissile material called plutonium-239. And the fuel, once it comes as a spent fuel, a time will come when 235 atoms are getting diminished. They are getting consumed in the reaction. Already they are very less, 0.7%. And when they come down to maybe 0.2 or 0.3%, we say it is no longer feasible to continue the nuclear fission reactions like in a reactor. So that fuel is taken out. We say that it's a spent fuel. And then India goes with that spent fuel for recovering uranium, plutonium from that. And because plutonium formed in the reactor from 238. Now, in this third part, we use the uranium-235 as well as plutonium, which is recovered from the stage 2, and then we put thorium in our in the blanket. And thorium, as I told little earlier, it is a fertile material, and so it will be reacting with neutron in the fast reactor and giving us 233. And this fuel will be a indigenous fuel. So if we have to run, we cannot run on the काठी. काठी means जो देता है ना, जो पैर में फ्रैक्चर हो जाता है तो काठी is given. So doctors tells you have to remove काठी if you have to. So if we have to be a self-sufficient, we have to bank on to utilize what Almighty has given to us in terms of thorium reserves. This is typical simplified version of a typical reactor. You must be seeing the core. The core is a central part of the reactor where the uranium fuel is kept, where the fission reaction will be taking place, and the heat getting generated. See, during fission, what is happening? A heavy nucleus is getting split up into two or more than two smaller nuclei, plus huge amount of energy, plus additional neutrons. Now, this huge energy it has to be extracted. So here we are using water to extract that energy. Water gets converted into steam, and we increase the pressure also, so that boiling point of water can be increased. Again, we are playing with the basic science. So, pressure cooker principle, why? Compared to normal conventional pressure cooker, water temperature goes, boiling temperature of water in the cooker is something around 130 degrees Celsius. Here is much more because pressure is more, and then it is the high pressure steam which rotates the turbine of generator, and that's how electricity is produced. This simplified part, but again, this gentleman is seeing the safety components, and we have what is called defense in depth, or a multiple barriers. Initially, there will be a reactor. You can talk about fuel pellet, and the fuel where it is written. It is a very strong or chemically stable refractory material we call zircoli, an alloy of zirconium and tin. Then you'll have a cladding material, coolant, primary containment, secondary containment. Then there is the exclusion zone. What I'm trying to tell, we have a defense in depth, a multi-barrier concept to ensure the safety of all environment as well as human civilization, while extracting the benefit of science, extracting the energy of the atom. At the same time, we want to make sure that it remains safe. Now we talk about the fuel options. All over the world, there have been two types of fuel options. One, we say once through fuel cycle, where the fuel is taken, put into a reactor, extract the energy, and spent fuel, which contains plutonium, which contains a balanced amount of 235 uranium. They just store it, and the worldwide, they have a planning to put underground, maybe something around 500 meter to 800 meters below the earth. They call them as a geological disposal facility. So those people are those country, those school of thought, they are coming under the category of open fuel cycle. On the left hand side, you are seeing the name of the country, writing from USA, Czech Republic, and all to 10 Switzerland. They are looking for open fuel cycle because of the various obvious reasons, including economical viability. But there are countries like India. We find that spent fuel is a resource material, number one. Number two, the spent fuel should not be put into the Mother Earth as it is, because of the large radiotoxicity content of it. So these are the countries: Japan, France, Russia, and all. They say that India is leading there. That spent fuel is not a waste, rather it is a resource material. So it is being reprocessed in India to recover plutonium which got formed in the reactor, and then remaining other components also, and they are being reused for different applications. So India adopted a closed fuel cycle. Again, I want to just repeat once again: take a fresh fuel, put into the reactor, then the spent fuel. Now the fresh fuel I can handle in my hand, bare hand. Fresh fuel I can put in my hand, bare hand itself, no problem. But spent fuel, because of the presence of fission production and all, will have a good amount of radiations and all, and those. So that has to be handled with the special containment systems. And this spent fuel, as I was mentioning, some set of countries they consider as a waste, but India has taken this as a closed fuel cycle. So we reprocess and recover the important components like your uranium is recovered, plutonium is recovered, and after recovering, they become a fuel for the future reactor. And remaining part, important point is remaining part when they were calling India, including India, along with the other world, we were calling as a waste. What it is? Fission products, actinides, and a bulk amount of unused uranium. Those were mentioned as taken as a waste material, and they have a again long half life. So there was a need for the again geological disposal facility for this. So India has a decades now. Just these are small examples of the country locations where we have a different type of reactors, and now we an ambitious program for expediting this nuclear program. And nowadays, you must be hearing that in addition to large reactors, we have been working for small modular reactors also, so that the downtime can be reduced and it can become more economical as well. So when you say front end and back end, so when you call back end, that means there has to be some front end also. So front end starts right from taking uranium from Mother Earth and then converting, dressing it in a fuel form, and then putting a clad and putting a reactor. So those part is coming as a front end part, but the back end means once it comes out from the nuclear reactor, when it gets consumed, and that time India has gone for a closed fuel cycle. So it makes two components. One is the reprocessing, where plutonium and uranium is recovered for reuse, so recycle and reuse. And examples of reasons have been many: conservation of natural resources, optimization of waste management system, minimization of environmental impact, and most important, which has kept our country into the driver's seat, that fuel cycle components like cesium-137, strontium-90, yttrium-90, ruthenium-106, they were once upon a time a waste component, and we all, including globally, worried about disposing again into the mother earth and all. Last 10-year works in India has really revolutionized the thinking. The color of thought pattern had changed, and now they are becoming a very important and invaluable component part, giving to what is called circular economy. So this is a reprocessing methodology. I may just skip because of the complications, or you can say complex nature of the process. Maybe these are some examples where we have a reprocessing plant in the country, and this again the process where how we reprocess the fuel. It is initially cut, the zircaloy is cut, it is dissolved, and then we play with again valencies of uranium and plutonium, and then go for what is called a solvent extraction system. What I'm trying to tell, a innovative technology where only uranium and plutonium is taken out, keeping the remainings, and then from uranium and Pu, they are separated from each other, and again, and they are used as a fuel for future reactors. So from Bhabha, right from the consumption of nuclear energy program in the country has given most important attention in terms of radioactive waste and all, and recycle and reuse, number one, and zero discharge of radioactivity to the environment has been the mool mantras right from Bhabha, who has been the architect of nuclear energy program in the country. So again, uranium and plutonium has been taken out from reprocessing. Another plant is waste management plant, where there were two options. One is convert into a glass, that is immobilized, and then dispose it off. But the innovation has gone. Is it possible to recover them individually, like cesium-137, strontium-90, ruthenium-106? They have been made in yellow color intentionally because they are having important use in for different medical as well as you can say cancer treatments and all. Similarly, for TRU, that is transuranics, naphthalene, americium, curium. There again, all they are called actinides. You might have heard if you remember our high school periodic table. At the bottom of periodic table, there are two lines. One is called lanthanides, one is called actinides. So americium is again a alpha emitting. You may be knowing the radiations are either alpha, beta, and gamma. They have different properties and nature. The americium 241, when I said 241 is nothing but the mass number. That is, mass number is called sum of proton plus neutron, which is in the nucleus. And now this americium 241 is alpha emitter. Again, it has been recovered by our country and is used as a what is called a heat source. And this component was also used in Chandrayaan 3 by ISRO for because in the semiconductors when the sun is not facing, when the Chandrayaan 3 is not facing the sun, the time temperature will become very less, and the functioning of all our semiconductor and device will become sluggish. So, and you don't this americium 241 and all, this is a heat source. And the 12th class principle, normally we read what is called a Seebeck effect and all. So we utilize this, and americium 241 also is equally important. Waste as such has got many elements. Just to show the complexity of this, look at these are elements which are present. And the earlier example was a periodic table that shows the periodic table itself is getting completely represented into the waste. Talk about alkali metals, alkaline earth. There is nothing left which is not there in the waste. Everything is getting represented in the table. What I'm trying to tell, it needs a very fine and innovative techniques so that the useful components can be separated from there. So these are the 3-stage program for management of high-level waste. The radioactive waste which is getting generated, it converted into a glass. Glass is an inert material, and again, man has learned from the nature. In district Thane in Mumbai, near Thane, we have a one area where maybe the geological survey of India is indicated that this is a particular picture, Vajreswari, hot spring, and they say there has been a basaltic rock where, because of falling of some meteorites and all, some 65 million years before, these glasses were formed, and these glasses were subjected for different detailed characterization and found, in spite of huge time left past, still there has not been much changes in the composition part, and which becomes the testimony that glass can accommodate these radionuclides and can isolate from human environment for extended periods of time. So worldwide, glass matrix is being deployed for management of radioactive waste. And these are storage when after the waste is put, the waste is converted into glass, and then again the radionuclides are there, so they will be getting heat will be getting generated. So we have to dissipate the heat. So they are stored for around 30 years so that heat is dissipated, and when they decay to innocuous level, innocuous means when activity becomes very low, and that time they will be disposed into something around 500 meters below the earth. This is the international level practice for disposal of waste. But now look at the scenario of India, and what India has done, which has put them into the leaders scale. I'm intentionally skipping this part. Yeah, look at this slide. If why this what India did to make it into the driver's seat. See, if the waste as it is, if nothing is to be done, then the radioactivity will take more than 10 lakhs and all of year come up to the natural uranium level. Why I'm mentioning natural uranium? Because anyway, it is existing in nature as of now, and human civilization has been existing. So if the waste after the reactor, that will take a long time when the activity level will come to the level of uranium, natural uranium part. And that means one cannot really wait for a long time to come. Though you have to remove the long-lived component. This is what was done. And here you see the picture in Trombay. We recovered actinides. It's americium 2 part, americium and cesium-137 and strontium. Those components which were considered as waste components, and indicating them they need to be converted into glass and then being later on stored and then to be taken for disposal. Now they are recovered and utilized for different societal applications. And how to recover? It has to be selectively recovered, and that will call all chemistry, engineering development. So we work on development, demonstration, and deployment mode. And this is how, as I was mentioning, that our Americium 241, what we recovered, was put in Chandrayaan 3. I'm sure you may be seeing the photograph where Sivan Saab, who was the earlier chairman of ISRO, was observing this when I'm explaining, and the present chairman, Narayan sir, that time he was second or third in command, he was also witnessing the same thing. Then this Americium 241, there was an MOU from ISRO and BARC, and that time it was given, and then it was used by ISRO for these applications. So what I'm trying to tell that waste is not waste, it is a resource material. See, cesium-137 and strontium-90, if we cover, it makes 90% of the radioactivity of the waste. And ruthenium is again 1 to 2% radioactivity. So if these all have been recovered in India, and they have been deployed for different societal applications. For example, we recovered cesium-137 from waste, and this was converted into glass pencil, which is being used as a blood irradiator. And as of now, more than some 20 hospitals where the cesium-137 recovered from waste, converted into cesium glass pencil, is being used as a blood irradiator. And you know where this blood irradiator is used? For a transfusion of, if a immunodeficient patient has to be given blood, the blood to be given need to be made free from all the harmful part. So the radiation to be given so that all harmful organisms and all will be killed, and that is done by blood irradiators. So our country was first in the world where the cesium-137, a component of waste, was recovered in large quantity and then deployed in a non-dispersible form for various societal applications. Similarly, ruthenium-106, again one of the component of radioactive waste, was recovered and is now being used for eye cancer treatment. Let me tell you, there was only one country in the world, Messrs. Vivek, Germany. In Germany, there's a pharmaceutical company, radio pharmaceutical company, Messrs. Vivek, Germany. They were only selling to all the remaining part of the world at a very, very heavy cost, making sure in India part the eye cancer treatment was away from a common man. The DAE at BARC, we recovered ruthenium-106 from waste, converted into a plaque, and this picture what you are seeing, this plaque is being used for the patient where the ruthenium-106 waste component was recovered, and this salvage of or the treatment of cancer was done. We have a look at the development part. Anyway, our president in that time, Mohanty Saab, is in the center. Presently, he is the chairman of Atomic Energy Commission. And on the left side, anyway, I was director there. And when we have given to the first lot in July 2019 for ruthenium after recovering from waste. And we look at, this is again, we have taken from one of the hospitals of Shankara Eye Hospitals, Bangalore. Look at how the eye cancer treatment is done by ruthenium, a waste component. The beta energy in this particular case, ruthenium-106 goes to rhodium-106 RH, which is having a beta energy of 3.5 MeV, and beta energy being range less. We wanted to only kill only the cancerous cell. The healthy cell should not be getting destroyed. So we utilize the beta energy coming from rhodium-106 and look at the cancer cells have been directly killed or destroyed. The right-hand side picture shows. And even the look at in 21 July, the army hospitals in Delhi, this poor child was having eye cancer treatment and utilizing the BARC recovered ruthenium from waste. That particular plague was used, and the vision could be salvaged of this child as well. And maybe this is again the certificate given by AIMS Delhi that whatever they were trying to use earlier, it was imported, and now they are telling that this is as good as or even better than what they were importing. Again, following the path of Atmanirbhar Bharat, maybe we have a 1 minute video clip indicating the same. It will start now. This is again, we made a software program so that doctors can see, depending on the magnitude of the or severity of the tumor, one can decide how much time the radiation has to be put for the eye for ensuring all the tumors to get cancelled. Maybe just the video clip for 1 minute.
Bhabha Atomic Research Center, the premier R&D center of DAE, is engaged in developing technologies using radiation for healthcare applications and treatment of cancer. BARC has indigenously developed ruthenium brachytherapy (RUBY) plaques for eye cancer treatment. Ruthenium brachytherapy is being used globally for treatment of eye cancer. In this treatment, a ruthenium plaque is placed on top of the tumor. It delivers selective radiation dose to the tumor without damaging the healthy tissues of the eye. This treatment modality is safe and has a very good track record of vision recovery and eye salvage. Ruthenium plaque contains ruthenium-106 radioisotope. It is produced in nuclear reactor by fission of uranium-235. This fission byproduct from spent fuel is harvested in its purest form using a series of separation processes. The recovered ruthenium is further electro-deposited on silver disc, which is sealed and formed to produce the ruthenium plaque. Ruthenium plaques of round and notched configurations are being produced for the treatment of eye cancers. The notched configuration is suitable for treatment of eye cancers located adjacent to optic nerve. The notched and round plaques are used for treating eye cancer like uveal melanoma, conjunctival lymphoma, ocular surface tumors, retinoblastoma, etc. Complementing the RUBY plaques, BARC has also developed plaque simulation software to assist doctors with optimal treatment planning. The software provides an easy-to-use interface for calibration and dose rate distribution of the RUBY plaques. It predicts treatment duration and dose received by other healthy parts of eye. Ruthenium plaques are being used for eye cancer treatment at several hospitals in India, including Center for Sight Hospital, Hyderabad, Aarti Center, AIMS, Delhi, Sankara Eye Hospital, Bengaluru, Army Hospital, Delhi, Hinduja Hospital, Mumbai, Fortis Hospital, Gurugram, Haryana. More and more hospitals are progressively adopting ruthenium plaques for better and cost-effective treatment of eye cancer. These plaques have gained the trust of the doctors and the patients alike.
Development of an indigenous ruthenium plaque by BARC will really revolutionize the management of eye cancers in India and this part of the world.
We at Dr. RP Center, All India Institute of Medical Sciences, New Delhi, has been using this BRC Ruthenium-106 ocular plaque for the past 1 year. The results are very satisfying and encouraging. The plaque handling are very much at par with the internationally available Ruthenium-106 plaque.
BARC is now developing pediatric plaque for treatment of retinoblastoma and crescent moon plaque for treatment of cancer near the cornea. Ruthenium plaques are available through Board of Radiation and Isotope Technology. Indigenous development of ruthenium plaques and the plaque simulator are major breakthrough in the area of Atmanirbhar healthcare and providing affordable treatment to eye cancer patients in India.
So this we have seen how this is recovered and being used. Similarly, strontium 90 also is being recovered and being used for therapeutic applications. So now look at, if you remove on the useful components, the volume of waste becomes very, very small. So that means it has got multiple advantages. Hindi mein bolte hain aam ke aam gutliyon ke daam. Extract the energy, produce electricity, and what the so-called becomes waste. That is a input for the other process. So that's how I was saying it is the circular. It gives a birth to a circular economy process. So impact of partitioning, as my saying, volume becomes very less of the waste. Conclusions now may come that this really will cut down considerably the requirement of geological disposal facility. That means go to the 500-meter depth of the earth and dispose of all the waste. And the benefit of science is to be taken today. Why the future generation need to worry about it? That means we have to make sure that there should not be any part of disposal facilities and all, and the solid waste, the radioactive waste, we have to make sure it becomes a reactant, it becomes an input for the other process. That's how the circular economy gets come into picture, and it also makes the overall process economically as well. This is again showing a similar thing. Generation of, I think this is more technical in nature. I can come out from there, because this is what normally being used in hot cell, so that man need not go near the radiation. Robots and all are being used. So that anyway, I can just presently, because it may take more time, but the intention is that all due required advanced equipments are being used for ensuring safe and secure type of working. We have a near zero discharge of radioactivity to the environment. We use all developed process so that discharge of radioactivity is zero. That is what is very important for us. But let me tell you, even if in our on your forehead, any one of you who are listening, even if I have a sensitive counter, a radioactive measurement equipment, if I put on your head, it will show presence of radioactivity. You know why? Because we all take tea, we all take milk. So potassium 40 comes along with the calcium. And so potassium 40 is there again in our body. Similarly, from the earth also radiation comes. That means human being have been existing in the environment of radiation from not from now, right from the mother of earth itself. But question is the quantity of the radiations. So this shows that we use the advanced chemical processes, ultra filtration modules, reverse osmosis modules, ion exchange modules, and I'm sure that the processed water, when the wastewater comes, is being reused again. Maybe not for these are for the low level radioactive waste to water, means waste got converted to water, and that water is being reused for the plant. So it helps it minimize the water requirement as well. So this is again in the low level waste how we do. Again, the volume is minimized. We use plasma also source. We use resorcinol formaldehyde, and very small amount of waste are being disposed into the nuclear institutional control. And they are decaying. You know, main difference between chemical waste and nuclear waste is chemical waste, for example, potassium cyanide, that will remain equally toxic as a function of time. Either you consume today or after 100 years, the result is going to be the same. But in case of a radioactive waste, since it's decaying, today is a waste, tomorrow it may not. Because of that decaying, it becomes to innocuous level. So the short-lived radionuclides are being disposed in a specially made engineered modules within the institution of DAE, and within a given time period, they are getting then decay to innocuous level. Now, these are just example of the engineered structures which are being used. Now we look at the offshoot applications. This is again a sewage treatment is done by radiations. This is another important applications. Now, whatever we have done for the development, this gentleman is looking whether it is having any application other than non-nuclear as well. Now, if you look at your municipal solid waste and liquid waste, I can give an example. This municipal solid waste, almost this has been the story of all our cities of the country. And although all governments have been trying to have a religious adherence of segregation and all, but I would request all the listener, are we really doing religiously? Probably there is a good scope to improve it further. And this picture is Gazipur in Delhi. Almost the heap of this is very close to the height of Qutub Minar. And open dumping and then open burning and all. I don't know if you remember. I would like to tell you that if you openly burn, there are a lot of poisonous gas, which are having very low concentration of threshold limit values are cancerous and all. They go to the atmosphere now. So these need to be treated. How we do this? We have again tried by what is called plasma gasification, and every gram of municipal solid waste, let it be polythene bag, they are non-degradable. But if they are all having calorie, maybe around 20 to 30 calorie per gram, they have some calorific value of this, so they can be suitably utilized, and they can become a heat source for heating waters and for other applications. And the waste also can be utilized, can be managed, because otherwise, if you look at a lot of cows and all they are eating, they are non-degradable and they are making our soil also infertile. So this is plasma gasification is one important part which is being used in BRC, and now at Tarapur we are trying to make a small model for municipal solid waste, so that later on the states also can have look. Presently, it may not be economically part, but जब initially mobile आया था तो where mobile was economical. So when things are being utilized on a mass scale, economics again will reappear. But first of all, we have to worry the ever increasing part of municipal solid waste in the country. Similarly, you look at the effluent. Again, you talk about Surat or any city for that matter, the effluents are being put and the water becomes highly polluted. Again, the hybrid process, what we are using for nuclear liquid waste management, can convert into the clean water as well. So this is how an offshoot applications. And for the COVID part also, BRC tried an indigenous mask. And many people, rather including all of us, have used Chinese-made masks. They were non-usable and non-degradable as well. And it resulted in the huge volume of non-degradable waste as well. So this anyway it's an offshoot application when we converted into and this is a transparent mask, replaceable, that cartridge can be replaced, and so that even the crimes and all can, because the face is seen, normal face, you cannot see the face, and it resulted in so many crimes. This was developed and it was appreciated by honorable ministers also, and it was being used. Artificial intelligence and nuclear energy is a new part where AI is again, it helps in nuclear energy to make it more, it automates. So radiation exposure to human being gets reduced. And the last few slides indicate how we are viewed by this international fraternity of the developments. Look at this gentleman is from Japan, overseas reprocessing plants, and they say that we envy you. When this fellow, because Japan again is supposed to be a developed country as such, but they when see the technology where waste is we recovered and utilized for a very important societal applications, including the space part and all, and cesium 137 for as a blood irradiator. USNRC, Nuclear Regulatory Commission, Stephen Byrne, when he came, he was the chairman of USNRC. He also writes that he was impressed by the operations to create cesium 137 in the solid balances as well. Similarly, CEA France, again a big name in case of a nuclear technology. He also congratulates the BRC, and he finds that very impressive and open new facilities for wide use as a medicines. And again, Japan, this is Parliament when they came here, Parliament committee, and they were telling, oh, we need your help in Japan. Thank you so much for enlightened by the information. So I come back to the essence of what I have discussed in an hour and 15 minutes or so, that Indian experience of 15 years is comparable to any best practices internationally. Reprocessing, that means we go for a closed fuel cycle, and the advantage we have indicated that not only we are reducing the radius of toxicity of the Mother Earth, rather we are able to utilize them for different applications like cesium 137, strontium 90, and 1892. Our innovation at the back end part was in the need of that geological disposal facility need itself now. We are thinking, do we really need, once everything is getting utilized in one way or the other, the residue of one becomes the input for the other. That's what, as I was mentioning, giving a birth to what is called your circular economy. This expertise can be significantly contribute towards improvisation of municipal solid waste. We have seen how Swachh Bharat Abhiyan can be visualized by having a plasma classification. So this is again, I was honored to have this Gandhi Award in 2022 for this works. And if you look at the waste volume, the lady that finger, this is the volume of the waste which will be disposed when an Indian family with the husband, wife, parents, and all, they use the energy from nuclear technology from all their life. If an Indian family utilizes the electricity getting generated from nuclear technology, the volume of radioactive waste will be an equivalent to a volume of a finger. That's what when we say low carbon and nearly renewable, hardly any waste comes from that. With this, I really thank for your patient listening. Thank you so much. And now the session is open for discussion. Thank you so much.
Yeah. Thank you so much, sir. I request anyone, if you have any questions, please ask. So you can stop the screen share.
Okay. So I can minimize, no?
Just stop share. Yes, sir. And open the Zoom.
Open the
Stop
Zoom.
share. Open Zoom and click on the stop share button.
Just a minute. Oh, yeah. It is now fine?
Yes, sir. Fine.
Okay.
You all can unmute yourself and ask questions.
Yeah, it will be my pleasure for responding to the queries depending on whatever little I have learned during the period of more than 36 years working at Bhabha Atomic Research Center.
Sudesh Sharma, sir.
Uh, Good afternoon, sir. Amazing insight, amazing presentation. I really, we are honored to have you on this platform and share so much in-depth information and, knowledge. So there is a small misconception which goes around that are nuclear plants safe? So how about you touch on that a little? So, because that's a raising concern. See, I think the way nuclear plants have been set up, they've been set up on outskirts. They need a lot of water, and then the floating thing that it's a very covered kind of a thing, and it has to be too away from where the inhabitation is, gives that perspective that it may not be as safe. So if you could throw some light on the safety barriers, controls, from a common perspective, it becomes better to understand.
Very important, very correct. See, as I touched a bit upon, like for example, the uranium, the invention of uranium itself, it was in 1939. The fission process was visualized or you can say invented in 39, and the first very use went for a destructive purpose.
Correct.
This is the only one probably example in the whole research scenario where the first use has gone for a destructive purpose, and that has probably a very strong impact on the mind of all of us.
Right.
And when we now talk about anything nuclear, inadvertently our mind gets connected to nothing less than Hiroshima and Nagasaki.
Yeah.
Now, let us come to the reactor part and all. And in fact, as you told rightly, that present reactors is a large capacity reactors. That's why we make out in the outskirts of city. For example, in Maharashtra, we have at Tarapur, something around 130 kilometers from Mumbai. And now we have seen that making even large reactors takes time. So even now, there is another called small modular reactors. And in fact, Modi ji has given a name BSMR, Bharat Small Modular Reactors.
Wow.
And they will be made for a big one colony also. Like Anushakti Mumbai will have one small modular reactor. And for Tata Colony, another small. That means in the city itself, they will have many small modular reactor. And the advantage being is they will be like assembled type of thing. They will be made somewhere else, and then they will bring the system and will be assembled. And if you look at the comparison, the time takes around 5 to 6 years for making a big reactor. Like Kakrapara took 5, and here we are almost thinking about 18 months. So the time taken part will be very less. It will be in the cities and all. So exclusion zone, what we are telling that away from, and then we consume water and all. So idea is that was for a bigger type of reactor. Now even small reactors will be put, and they will be every small village or every small town, so that we can avoid transmission loss also. At the same time, the small reactor will be constructed within a, like now there are some industries. I can mention about cement industry. I can mention about steel industry, and more importantly nowadays even data science. Data centers. I was shocked that data centers also they gave an inquiry. They want a nuclear reactor because they also need electricity. So nowadays this small modular reactor can become as a captive power. Like
Okay.
if your Tata wants or Jindal wants their own power for uninterrupted power for supply, so they can have a small modular reactor. So what I'm trying to mention, sir, is bigger reactors. Rather, yes, one thing is there that probably it is the only nuclear fraternity or nuclear process where a lot of emphasis have been given to nuclear safety. If you
Right.
talk about Bhopal, I think none of us have forgotten about our Bhopal cyanide eye, where a lot of people have lost eyes and all. Here we have gone for a what is called defense in depth. So multi-component system we have done, so that even in the worst scenario, nothing should happen beyond the institutional
Right.
control.
Right.
And Now, if you look at, even if you look at the number of incidences all over the world, we can count in fingers. In fact, we had in Fukushima, in Japan, we had in Chernobyl, and if you look at the loss of man and material have been much controlled compared to the other processes. So, other way, if you look at LPG cylinder, nowadays every one of us in all our villages, irrespective of the education knowledge, all of us are using LPG cylinders. Now, if we calculate scientifically, LPG cylinder is nothing but a small nuclear bomb.
Correct.
But all of us, we know that there is an advantage of this. Number one, how to use it, what do's and don'ts, that has gone at the back of our mind. Even our brother, mother, and sisters, they may not be technically so knowledgeable, but they are very confident in using those parts. And similarly, this nuclear part has not gone because of the fear associated with the first use, which has gone for a wrong.
Right. Sir, one more point I'd like to ask, sir. How, like they say, we have huge amount of oil reserves, and Rajamundry, we found some oil reserve. How good are we in our natural resources in terms of radioactive elements or our raw material in terms of availability and the global scenario, like going forward, if nuclear fuel goes to a level where, how oil and gas is today accepted and being used extensively, obviously the quantitative risk assessment will be taken place, as you correctly said, that you will have a boundary or a perimeter set beyond which the QRA shall not expose the normal human life. Where are we standing, sir? Is our fuel comparable to that same level of oil and gas?
See, it's a good question, sir. As I was mentioning, you talk about the fuel. We know all time that for thermal power plants, we have a coal, and that too also in India, coal quality is not that good.
Not good.
Ash content is very high. Now, compared to nuclear, as I was mentioning about nuclear uranium, we don't have a good reserves of uranium.
Right.
But whatever reserve we have, there also uranium-235 content is poor. So, but Almighty God has given us in a good compensation by giving world 1/3 reserves of thorium-232.
Wow.
So now Dr. Bhabha, right from 1956 onwards, he has made a script of policy that our innovative technology should go towards exploitation of this fertile thorium-232, which we have in penalty, to convert into uranium-233. And already there is a reactor in Chennai working on this for, you can say, research reactor, experimenting on this. And based on the data, there has been already an announcement by Government of India for making a thorium-based reactor at Tarapur.
Wow.
So, to nutshell, I can respond that our fuel, we want to, is a one work in the direction of self-sufficiency. Number one. Number two, in a small modular reactor, when we are talking about, we'll be using enriched fuel.
Right.
And presently, we have to bank on importing it for the time being. But good thing is, एक बार वो fuel डाल दिया, for 10 years we have not to worry.
Correct.
So the small modular reactor has an advantage that volume of the waste which will be getting generated will be very small, because once we put for 10 years, you keep on taking the advantage, and the waste volume will be very less, and then that will be recycled. That waste will not be thrown, will not be disposed. That will be recycled, recovered, and then again converted into a fuel again.
Amazing, sir. Thank you so much, sir. We have a couple of questions in the chat box, and we have Sharmaji also with you. And Anandji, you've raised your hand. If you have a question before we read out the ones in the chat box, you could unmute and ask your question. Yes, Anandji.
Good morning, sir, and thank you for a very good session. I have one question with relate to the sustainable energy, because as the whole globe is towards ESG. So with this energy, is one question is this nuclear energy is truly a renewable energy, and how it is compared with green energy like solar and wind, other energy.
Yeah. Thank you so much for this. This is a very important question, sir. Thank you so much for giving me an opportunity to touch on this question. So let us first maybe spend a minute or so on the renewable part. One is the solar energy, and maybe when we say the grid stable voltage. As of now, the hydro and solar part, we will not be able to run our heavy industries in spite of the good incentive government of India is giving, because as of now you may be knowing that all over the world the energy storage system is one area where people are working on for the solar. And second, the solar panels, they also contain very toxic elements like chromium, like your the semiconductor devices which are made, and over a period of time, because of the deposition of dust on it and all, and the efficiency goes down. So it is very well that presently we have to work on what is called energy mix. And only I make a statement with the full authority that only your solar and hydro, they are welcomed, but they will not be able to make the stabilized grid voltage. So grid stabilization needs a sustainable uninterrupted power of nuclear supply, which as of now nuclear energy only can put. So I again tell, we will be working, we'll be using solar, no doubt about that. And that will be a hybrid for solar and nuclear. And one step more, that the hydrogen now, see, we don't want to remain up to solar, remain up to nuclear. Rather, also we want to go for hydrogen as the future fuel. Now we are now people are talking about brown hydrogen, green hydrogen. So the hydrogen we are looking for, a green hydrogen means we have plenty of water, and electrolysis of water will be the one process where one of the process where hydrogen can be generated. But electrolysis water will need some energy. That energy will come from the heat generated, or heat which as a waste energy of heat coming from nuclear reactor. That will convert water into hydrogen. The nuclear energy has an additional advantage, which is not in solar and all, to give an opportunity to us to go to a hydrogen part where the hydrogen and oxygen from environment will give energy, and water will be the waste product. So that is the eventual or ultimate fuel where the whole scientific community of the globe is looking for.
Thank you, sir. Thank you. And this will be considered as a green energy too?
Absolutely. As of now, if you talk very clearly, we are defining your solar and wind as a green energy, and nuclear as of now we are talking about as a near green energy, because you must have seen one of my slide where I have indicated the footprints. So the footprints, in the footprints, even the coal, and then there I have indicated solar also. So the how much for 1 kilowatt hour, that means for 1 unit of electricity, how much CO2 you are putting into the atmosphere. And for nuclear it is around 12, and 12 gram equivalent of CO2 will be getting pumped into the environment if we consume 1 kilowatt hour, 1 unit of electricity through nuclear plant.
Thank you, sir. Thank you.
So we have few questions in the chat box. One is
Yeah.
in the
So-
nuclear, by Sanjay Chauhan, sir. In the nuclear fuel, which is the main element involved, and what is plutonium?
अगर ये लोग आके इस तरह इनकी हेल्प करने लग जाए ना तो फालतू दुनिया
Yeah, no problem. No, it is always welcomed because this is one important part of our outreach program, and rather we even wanted to go to all schools and colleges so that our young generation, Modi ji keep on telling that more than 65% our 35 years and below. So if they understand the nuclear part and all, they will become the ambassador of nuclear. So coming to the question that, plutonium is a radioactive material. It is a not existing in nature. It is formed in the reactor. How it is formed? When natural uranium, when I say natural uranium, that means it contains two isotopes. One is uranium-235, another is uranium-238, and 235 is only 0.7%, and 238 is 99.3%. Once it is in the reactor, it is interacting with the neutron. Both are interacting with the neutron. 235 is undergoing for fission, and 238 is not a sleeping partner. It is interacting with neutron. So uranium-238 plus neutron, it gives another element called neptunium Np. Neptunium-239 having a half-life of 23 minutes. And then neptunium gets decayed to what is called plutonium-239, which is a fissile material. So plutonium is a radioactive element, it is a fissile material, and it is invaluable. There is no price tag. No country will give any plutonium. So plutonium is very important for having a fuel for future reactor, number one. Number two, it is very important for strategic applications as well. I hope Chauhanji, I'm able to respond properly, or you want any elaboration? It will be my pleasure.
Sir, it was I think mesmerizing. All the points that we look forward to in a topic like this have been not only adequately but very impactfully covered by you. And as Sumit ji said, because he has been listening to various presentations on similar topics in this forum, this one was very exhaustive, definitely very exhaustive. And you gave all the logic and you gave all the reasons. And I think there is no...
Sharmaji, but still it is my appeal to all that any question, not even now, afterwards also it is coming in mind, it can be emailed to me, and whatever little I have learned from the society, I have to give back to the society. So it will be my pleasure to respond whatever little I know.
Sir, one idea, sir, one I would like to give to ICS and Sumit ji particularly, आपने defense in depth का mention किया था ना? So defense in depth would be a very new topic for participants of this webinar. So at some point of time, I think we would definitely love to have that topic from you, defense in depth.
Sure.
And that defense in depth will apply not only to nuclear, it will apply to all kinds of industry.
Correct.
Chaliye, thank you, sir. Thank you.
Thank you so much. Any questions, please? And even if because of some hesitation, if any one of our listener is not able to, please email to me also, because important requirement is that the myths, lot of myths need to be get erased from the mind, and then only, because I have seen in other countries like France and all, school visits are made, and when our future scientists, when they are of 8th class, 9th class, they are taken to nuclear facilities, and when they are being taught by देखो ये फायदा है, ये नुकसान है, and then no anti-nuclear lobby will be able to take advantage. as of now, since this is not getting exposed, rather the Department of Atomic Energy has now realized. See, in our so many of our nuclear power plants getting delayed because of the function of anti-nuclear lobby, and that can be done handled if we have a good outreach program. When our younger generation, they take a command on it, and how they take, when the truth is served in a fashion. Look, this is the advantage, this is the limitation, we have to handle with care, the way we are handling LPG and others. So these are the advantages. Our environment will be preserved, CO2 will be less, climate change will be less. All those things can be put in an illustrative manner.
So we have 2 more questions in our chat box.
Please.
By Janul, why we are not only using nuclear power for electricity, as nuclear power can give electricity to the entire India for years with its small efforts.
Very important, right, sir. We are trying to utilize nuclear electricity with the help of nuclear technology. That is what has been the you can say dream of even Modi ji and all. Because why? Because it is a low carbon, near renewable. So nuclear energy using for electricity production is the need of the hour. And when our Honorable Prime Minister is telling by 2070 we'll have a net zero carbon, it indicates India is going ahead for nuclear. And now Government of India also has understood that our corporate people also have to come in picture, because पैसा चाहिए ना भाई लगाने के लिए. तो now even you must have seen our Honorable Finance Minister also has given expression of interest part, where Jindal se leke, then Reliance, Adani, those people are coming. And the day is not far away, gentlemen, when we'll have many small modular reactors operated by our private part, because there were 2 things which were hindering. One was Atomic Energy Act in 1962 wala. Second is your CL&D Act. अभी जो मानसून का पार्लियामेंट चल रहा है ना, इसमें ये दोनों एक्ट गवर्नमेंट ने रखे हैं to allow them means to allow our corporate culture, corporate persons also to own the nuclear reactor. So आपका मुंह में घी शक्कर, because ऐसा टाइम आने वाला है when we'll have many nuclear reactor, and electricity will be there at the same time. Carbon will be net zero, so that we can avoid this climate change where CO2 is main responsible.
Thank you, sir. And one more last, is radioactive waste safe for future generation?
Yeah, I indicated that now with last some 10 slides, nothing like waste. Waste is a wealth. See, radioactive waste का मतलब क्या हुआ? Initially, our earlier understanding was, then once we take out when the energy is taken, the spent fuel which contains a lot of fission products, it is called as a waste. That is what normally was the convention. But what India has done from the last 10 years, we indicated, अरे ये waste को waste क्यों बोल रहे हैं हम लोग? Then we started looking waste में होता क्या है. Then they have found cesium-137 is one isotope which is called as a waste. Strontium-90 which is called as a waste. Americium-241 which is called as a waste. Then we realized that they're all useful. Then why? Then malum pada, there is a need of a complex technology to separate it. And then India worked for 5 years for development of those technology, and we separated cesium-131 separately, strontium-90 separately, americium-241 separately, and आप लोगों ने वो 12th class में पढ़ा होगा Seebeck effect. Seebeck effect, radioactive heat itself is a source. तो एक cold junction रहेगा, एक hot junction रहेगा, and EMF will be getting generated. This is what the fundamental part of Seebeck effect. तो americium-241 को Chairman ISRO, I think you must have seen the photograph of Sivanji where I was explaining in the slide. So the americium-241, which was a part of a waste, we recovered, and then that was put in a Chandrayaan-3 to provide heat. so that all our semiconducting devices can work out of their performance because of the temperature. Similarly, cesium-137 आपने देखा कि वो एज ए ब्लड एडिटर यूज होता है, रुथेनियम-106, ये सब वेस्ट थे. अब वेस्ट कहाँ रहा? Now those waste has become a part of wealth, and that's what I was talking about as a circular economy.
Thank you so much, sir. If anyone has any questions, sir, we will write a mail to you.
Please, it will be my appeal, a handed whole appeal. Please email any question. Let it look foolish. Doesn't matter, because it becomes my moral duty also. Whatever little I have learned from the society, from our gurus and all, I need to give back to the society. Please make sure all the questions, wherever they are looking logical, illogical, let them, and to the best of my understanding, I will try to respond within a given time frame.
Yes, sir, noted. Today's information on the topic was very useful, sir. Thank you so much.
Yeah, thank you so much for giving me an opportunity as well.
Moving ahead, ICS is pleased to provide you all its research and development. We have the books available in IMS, Integrated Management System, Excellence in Education Management, ISO Made Easy. The books are available in different languages, Gujarati, Marathi, Telugu, Hindi. If anyone wants to purchase, you all can contact the below. Urja. We have launched this Urja book. It is written by Dr. Sundar Kataria, and this book is dedicated to the scientists and engineers. If anyone wants to purchase, you all can please contact the below. Feedback form. Please register on www.sadgunsang.org and go in your login and give your feedback. We officially close today's Sadgun Sang. Thank you for being a part of today's webinar. Thank you, everyone.
Thank you so much. Thank you so much.
Thank you so much, sir. Honor to have you, sir.
Thank you. Thank you so much.